Hi, this video is part of the Core Services series. So it will build upon the first episode in this series where we created a Linux server virtually in a VirtualBox. And if you haven't done that, you don't have a Linux server available, you can go to the first video in this series and follow along. That will help you create this server. And there will be a card here or a link in the description or something like that to that video. We will be building a WebODM server to process drone imagery in this video. So in the opendronemap.org site, there's a page called WebODM with information about what WebODM is and what it can be used for. But we'll get back to that in just a little bit. First of all, this server, I don't want to change it. I want to be able to use it more. So I will clone it. So I will right-click and select clone. And the new one should be WebODM. It's just a name for the virtual machine. Everything else will be kept as the settings we set for it when we created it. So just keep anything else default. And it should be a full clone. And this will take a little bit of time, not too much. It will just copy the files for the server. There we go. Now we have a clone of the original server, and we can just start that one. And I don't need to see anything else about this. And I don't need to see this either, but it's nice to see when it has finished booting. So I will keep it up until it's done booting and we get to the login screen. There we go. I will minimize that window. Let's open a terminal. And the same way as we did before in the installation video, I will SSH into the server. And since it's a clone, it will be using the same IP address. So you shouldn't run more than one instance of the clones if you are creating multiple clones. So the password. That was probably wrong. Yep. There we go. Let me clear that. Let's go back to WebODM. So you can read up on WebODM. I will not go into details. There's nice videos and a lot of information on the web page. So I will go to the download. And we will do a manual installation. You can use the ODM installer, especially if you want to do this in a production environment. You should look into the installer for Windows servers, or if you want to have support for your installation. But this will just be a manual installation for you to try things out. So we will go to GitHub. And here you will scroll down and down and down and down to getting started. So for this, we need a few applications. And this will be installed using this terminal. And to install applications, we used apt to update in the server video. We will use apt to install here. So sudo elevated privileges apt install, and then we just list the software we want to install. We want to install Git space Docker space Docker Compose Python, and I know that Python is not a valid name. It should be Python and a version, so I will select Python 3, and we want to install pip. These are resources that is required for WebODM and OpenDroneMap to run on the server. So press enter and the password. And we will confirm. And now it will download the packages. And we can expand this window. And when it's done downloading the packages, it will install them automatically. And we're done. Now we need to get the WebODM software, but first I will actually do this. The user we have is not part of the Docker group, and it will help really a lot to have the current user a member of the Docker group, and this command will see to that. So I selected and copied this row here, and I can paste it in here. And the command is sudo, that's elevated privileges, user modify the user, some options, and the group is Docker, and this $user, that's a variable that contains the current username. So run that, and for this to take effect, we need to exit the terminal, and in this case it's easier just to reboot the server. So reboot. Permission denied. We need to elevate our privileges. Sudo reboot. The connection is closed and the server is rebooting. If we have the ability to look at the server, we can see when it has rebooted. Otherwise, we can just wait a while and try to connect with SSH in a minute or two. There we go. We're back in business. Clear that. Now we need to get all the files we need to build this server. So copy this git clone command. So git we installed previously, and the clone option is copying anything from this git address, and the extra information is to limit it to just the most recent version of the installation instructions. So it will not download all that is needed. It will download instructions that are needed to build the Docker container for the server. So it's pretty quick here. But then we need to go to the folder, the WebODM folder, and we need to run the command that is printed here. So /webodm.sh start. This will start pulling or downloading all the files needed, and when that is done, it will build the Docker container that will serve us the entire service. So this may take a while, but you will know when it's finished. So again, I will speed up the video for you. And now the installation is done, and it's starting the application of the service. And we should get a small message anytime now. There, congratulations. And we get an IP address that will work on the local machine, but we can replace this local host with the IP address of the server. Before we do that, I will shut the service down by pressing Ctrl+C. That will gracefully stop the service and the different parts of it. We could force it, but I will just let it play out. It shouldn't take too long for it to shut down completely. So we'll just wait for a few seconds like that. So the command we used, WebODM.sh start. The WebODM.sh, that's just a command file. And the start is the command that we send to that file. But if we run the script or the command file without any option, we will get some information about what we can do. So the available commands are start with options. We can stop and remove the Docker containers. We can update them. So if you know that the WebODM has been updated, you can give the command update. Then it will pull down all the new files and rebuild the container. And a few others. When we run start with options, we can do it with a different port. The default is 8000. If you have a server with a dedicated GPU, I think that is for NVIDIA only, but I'm not sure. But if you have a server with a dedicated GPU, you can add this after the start command. So the start command should be .dash. This only tells us that we are in the current directory. So web, I will tab to autocomplete, WebODM.sh, that's the command file, start. And if we want to change anything, for instance the port, we can do -- port, and let's try port 80 instead. See if that works. I haven't tried it. And enter. It will do some checks, and then we should be up and running. Yep, congratulations. And we will see that we have this IP address instead. So now I can open a new tab in my browser, type in the IP address for the server, 192.215, and we should add the port here, but I think that if I use port 80, I don't have to. Yo! We get a welcome screen confirming that the installation worked, and the first thing we need to do is create an administrator account for the WebODM service. So in this case, when I tried it last time, I used WebODM admin. I I will use that again. I will create a secure password. So this is the administrator for this service. And this is what it looks like. You can go into administration when you are an admin. So you are admin, you can log out if you want to, but you can go into administration, manage accounts for this, manage groups, you can change the branding, and in the settings you can theme your service, change the colors and whatever. You look at plugins and other stuff. Yeah, but the exact process of what you can do in WebODM is for another video, or there are other resources on the internet you can use to find information about it. I just want to create some data for the back-end service to QGIS. So let's say we have been out flying a drone or taking some pictures with a handheld camera or the phone. So I will use this first project and edit it and call this my first drone shots. I can type in a description, some water and terrain. I can assign permissions, add users with different rights here, and that's it. I will upload some images. I think I have some here. Like that. And we will call that river. You have some default options. So if you just want a quick ortho photo, you can select field here. That's a new feature when I'm recording this. So maybe I'll try that. No, I will go with the default. But depending on what you have captured in your images, you can select stuff here. And you can also edit the settings manually. The option you choose here will select the appropriate settings for you, but you may want to change things. So when I use a GoPro, for instance, I usually go in here and set it to fisheye because I usually use the widest angle of the GoPro. But you can go through here and change any settings you want. But I will use the default. The resizing of images, that is so it will be quicker to process. It will not resize the resulting imagery. It's just for the processing that it will be resized and therefore quicker. So let's review it. Everything looks fine. Start processing. So what happens is the photos are uploaded to the server, and we can already view the area on the map if we want to. So it will continue here, but we can view it on the map. No, we couldn't. So let's just update. So we are resizing images. I was too quick, I think. And we can expand that one, and we can show the task output. So when it has finished resizing the images, we will see some form of output here. So if you are so inclined, you can sit and watch this display of information and follow along in what the application is doing. Otherwise, you can just relax and leave this. You don't even have to have the page open. Everything is handled by the server. So let's see. It will still be here and processing. And depending on how many CPU cores and how much RAM you allocated for the virtual server, this could take a while. So I will pause the video and get back to you when this processing is all done. Yeah, so this wasn't too bad. It took just under 40 minutes to complete. And the time it takes really depends on the hardware you are using, but also the photos you're using. If it is drone imagery or handheld imagery, how much overlap you have, and etc. So this seems to have worked. It generated 5 million points, roughly, over an area of 17 hectares. So it's a reasonable area. So now I guess we can view this on a map. And now it's pulling some, I don't know, Google Maps from the internet. And I hope it will overlay my orthophoto here. There we go. So it's a reasonably sized area, and you can view the image directly in the browser like this. There are some other viewing options, like this plant health. It will not give any truthful meaning to the view unless you have multispectral imagery. But at least it will try to excuse me, try to use some information to portray a notion of plant health. But it's really not valid in any significant case. You do get a surface model, and that is more or less elevation data based on the process. And you can do some things in this view directly. If we switch to 3D view, we will get the point cloud in a pottery viewer. You can also add, show the cameras, the location of the cameras, and if you find a camera location you want to look at, you can just click it, and it will show you a preview, and you can view it in full screen if you want to, like that. And you can also view the textured model instead of the point cloud. I don't use that really often, but in some cases it's nice to look at. In this case it seems to be a bit slow to update. So a quicker computer with more resources could probably help. What else? You can control the point budget, because the data that is shown here, it does have a lot of points, 5 million at least. Exactly how many we will look into a bit later. But it is tiled in an optimized way with an octree tiling. So the closer you get, the more points are included. And to speed up the viewing, you can set how big of a point budget you have. So when it reaches this number, it will stop draw the points. So if I increase this, you will see that the density of the points will increase. So if I decrease it a lot, it will be really quick to draw, but it will be a bit sparse between the points. So if your computer is slow to update, you can change the point budget. And you can switch between some backgrounds, increase the point quality. That essentially is the shape of the points. If I increase the point size, that is under scene, point cloud, and point size, MESA things. And standard is square points, high quality is circular points. So that is that. One is quicker than the other. And you can do a lot of other things like make measurements, take measurements. And you can move those measurements. So distance, elevation, areas, and so on. All these measurements can also be exported. So you can, if you want to use it in QGIS, just export it as DXF, and that file can be immediately viewed in QGIS. So let's just do that. Doesn't matter what I use here. And let's just start QGIS. So when I clicked DXF here, it downloaded into my downloads folder as measure.dxf. And let's see if I can get QGIS to the right window, like that. And a background map, the same maybe. And then we go to downloads folder and measure and drop it in and apply those layers. And we can zoom to that. Is it in the right location? Of course not, because it doesn't know what projection it has. So I need to tell it that it is UTM zone 33, because I know it is UTM zone 33. And now we can zoom to the layer and see that it's hopefully, there's a bridge, there's a narrow gap, and let's see how it looks in the browser. There's a bridge, there's a narrow gap, so it should be just fine. Okay, you can do a lot of things in this web view directly. Not only create geodata that you can import into QGIS. All the data generated can be used in QGIS. So you have a download button right here. You can also use the dashboard. And in the task, you can download the assets. You can download everything into one zip file, or you can download different assets separately. So let's download the orthophoto, and we can select in what format we want to use. I will use GeoTIFF Raw. Can download the surface model. The same formats as options. Let's do Raw. The point cloud. Right now we can select LAS, PLY or CSV. I suspect that there will be an option to download as cloud optimized point cloud eventually, because that is possible to do from the command line. But for now I will just select LAS and we'll see what it is right now. The texture model can be downloaded, and camera parameters, not sure if that's something that is required. It can be useful if you use the same sensor in different projects, because then you can reuse the parameters. The camera shots, that's a GeoJSON, and a quality report, that's a PDF. This is really useful to keep with your downloaded data, so that you have some form of source report of when it was collected, how it was processed, what it contains, and the quality of the data. And you get previews of everything like this. And depending on your settings, you will get different results and different data. Okay. Let's go back to QGIS and download. Let's see what we have. Refresh. What was it called? We have River Orthophoto. River Orthophoto. There we go. And that should be a cloud optimized GeoTIFF. And it seems to be, because it's really quick. Yeah. Never mind. I think we'll jump out of Google. And we have the DSM, the surface model. That's elevation data. We have the georeferenced model LAS. And now we will find out if it is cloud optimized point cloud or standard LAS. It's a standard LAS because it's converted. It's converting. There we go. So we have the point cloud. Did we download anything else? Yes, we downloaded the river shots. River shots, that's a GeoJSON. And there we have the image locations. And the OBJ, the textured model, we can't open that in QGIS in a useful way, but it can be opened in, for instance, Cloud Compare. Let's see, Cloud Compare. Probably need to unpack it. Cloud Compare. And the downloads folder, river textured model, extract here, river textured model, and we have a OBJ file. Yep, that worked. And it's a bit slow. Anyway, this could be used in any software that can read OBJ. And if it's not enough, you can probably save it in a few other formats from Cloud Compare. And you can also use MeshLab to save it into a few other formats as well. So now we have a server for processing imagery using photogrammetry in a really nice and automatic way. It will not work every time unless you are really careful about how you take your pictures. But with this tool you will learn pretty quickly how to use it. If you have a drone and some software that is made specifically to collect data for this kind of tasks, it will probably work most of the times. So what else can we say about this? 3D view. So the point cloud is in 3D. The rest of the data is not automatically in 3D. So you can change, for instance, river shots, layer styling, 3D. We can set it as a single symbol. And a sphere with a radius of, let's say, 1, 2. And so this way you can use the point cloud tools in QGIS and the 3D view and the 2D view and anything you like with this back-end service that you have created yourself. I think that is all for this time. And in a coming video, we will probably take a look at some other form of back-end service you can use in the Linux server that we have created. So see you next time.